Hello everybody and welcome back. In the previous video, we have seen how to connect 4 external LEDs to the Raspberry Pi Pico and how to blink them simultaneously. Now in this video, we will use that same connections and we will see how to create a sequence of running LEDs. So imagine this is LED 1, 2, 3 and 4. So the first LED should turn on and stay on for a particular amount of time, and it should go off, and then the second one will turn on and stay on for a particular amount of time, and it should go off, and then the third one, and then the fourth one. So they should turn on in this order: 1, 2, 3, 4, and again 1, 2, 3, 4. So that is what we want to achieve here. So we will use the same connections that we have used in the previous lecture because the connections are the same. And if this is the first time that you are watching this playlist, and if you want to learn how to create these connections, then you can watch the previous video, which is the one where we discussed how to connect 4 external LEDs to the Raspberry Pi Pico and to blink it. So here we will use the same connections and I will not repeat on how to create the connections again. So let us see how to modify the code, or what is the code that we have for achieving this. So here I have already written the code for achieving this sequence of running LEDs. Let's see what they do. So in the first line here, I have declared an integer constant called numLED and initialized it to 4. And this represents the number of LEDs that we have. And secondly, we have a constant integer array called GPIO pins, and the elements of this array are 0, 1, 2, and 3, which are the pin numbers to which our LEDs are connected. So we can see that they are connected to pin numbers 0, 1, 2, and 3. And next I have declared another constant integer called run rate, which is equal to 500. Now run rate is nothing but the delay that we want to give to each LED. So it is the time that it has to stay on or off. Now coming to the setup function. In the setup function, like we already explained in the previous video, we want to initialize or set all our LEDs as output. So we are running a loop from 0 to num LEDs. So LED is the variable that we use for iterating over this loop, and it runs from 0 till less than num LEDs. That means till it becomes 1 less than num LED, it will run. So it will run from 0 to 3, 0, 1, 2, 3. So the 0th element of the array, first, second, and third element of the array is what we are trying to represent here. And we are saying that pin mode GPIO pin of LED output. So LED is the variable here, and as we said, it will go from 0 to 3. So we are essentially setting all the LEDs as output. So remember that our LEDs are declared inside this arrays, and because of that, when we say GPIO pins of 0, then it will refer to the first LED, and GPIO pins of 1 will refer to the second LED here, and so on. So all of them are set as output. Okay, now coming to the loop function here, we can see that I am calling a user-defined function called running LEDs. And as a parameter, I am passing a run rate, which was the delay that we gave here. So what is this running LEDs? Running LEDs is actually a user-defined function which I have written. So if you see here, this is the definition of the running LEDs function. So what does this do? Let's see. The return type is void, and then it takes one integer parameter called run rate. Okay, so run rate is actually the delay that we set. That means the time the LED should stay on or off. Okay, now coming to the function, we can see that I'm running a loop here from LED equal to 0 to less than num LEDs and LED plus plus. So LED is the variable that we are going to use for iterating over this loop, and this loop will run from 0 till 1 less than num LEDs, because we are using less than symbol here, not less than or equal to. Now let's see what happens. In the first iteration of the loop, LED is equal to 0. And is LED less than num LED? What is num LED? Num LED is 4. So is 0 less than 4? True. So it will come to the loop and it will say digital write GPIO pin of LED high. So GPIO pins of LED. What is LED? 0. So GPIO pins of 0. What is GPIO pins of 0? It is the first index in the array, which is this one. Okay. So array indexing always starts from 0. Hope you know that. So we are representing the first LED, which is connected to pin number 0, and that LED will turn on. So digital write is the function that we use for turning on or making the LED high. Then we give a delay of run rate. So run rate is 500. That means we are giving a delay of 500 milliseconds here. So what will happen? The first LED will turn on and it will stay on for 500 milliseconds. Next, we are saying digital write GPIO pins of LED low. So LED is still 0. So that means the first LED will now turn low or it will turn off. And we are again giving a delay of run rate which is 500 milliseconds. So that means the first LED will turn on for 500 milliseconds, then it will turn off for 500 milliseconds. Okay, now it comes to the next iteration of the loop where the increment happens and LED now becomes 1. So LED is equal to 1 and is LED less than num LED? LED is 1, num LED is 4, is 1 less than 4? True. So it will again come to the loop and it will say digital write GPIO pin of LED is now 1. So GPIO pin of 1. What is GPIO pin of 1? It will represent the second element in the array, which is pin number 1. So that means this particular LED will be set to high. And then we give a delay of run rate, which is 500 milliseconds. And then the same LED is set to low for 500 milliseconds. So this loop will continue for all the LEDs from 0 to 3, 0, 1, 2, 3. Okay. And once it reaches here, then this loop condition will become false and it will exit from the loop and it will come back to where it will come back to the loop function where it was called. It was actually called from here. And then what happens here? This function call is inside the loop function. And we already said that whatever is there inside the loop function will keep running repeatedly. So that means we are again calling this function. So when this function is called again, this whole thing repeats again. So that means again from the first LED, it will start turning on and then second, third, fourth, and the loop completes. That means the for loop completes, breaks from the for loop, comes back to where it was called and it was inside the loop function. So again, it will continue. So that's how we can achieve the sequence of running LEDs. Let us run this program and see if it is working as we expected. So you can see each of the LEDs are turning on and staying on for 500 milliseconds and turning off for 500 milliseconds. So it is going in this order: 1, 2, 3, 4, and again 1, 2, 3, and 4. Okay, so that is how we can achieve this. Now you can try this code and see if it is working for you, and also you can play around with this code, make some changes, maybe increase the run rate or decrease the run rate and see how it works. And also you can change things in the code and see how it works. So that is how you will learn by practice. Okay, for example, here we see that after it turns on, we are giving a delay of 500 milliseconds. And once it turns off, again, there is a delay of 500 milliseconds. So suppose, let's say that I don't want this delay. Let me comment out this code. And if I run this, what will happen? Just take a moment to pause and visualize what would happen here. So here what would happen is that because we have removed this delay, as soon as the LED turns on, it will stay on for 500 milliseconds. And as soon as it turns off, it will not have any delay. It will directly go and turn on the next LED. So we'll see that it is a little faster now, the sequence of running LEDs. See, you can see the difference here. It turns on, and as soon as this turns off, we can see the next one is turning on, and then it continues. So like this, you can make changes and see how it works. So I hope this was clear to you about how to modify our code to create a sequence of running LEDs. So I hope this was clear to you. Thank you for watching and see you in the next one.